All right, so we're ready for part 2 on the back. So we're going to take what we did on part 1, but we're going to add an extra step in the beginning, and that step's here. It's going to be to factor the numerator and denominator completely. Okay, so completely means to make sure that only prime factors, so take it down as far as you can when you're factoring. So this is going to take us back to what we did when we factored polynomials. You do have notes for that, and I have posted them on Google Classroom for you to reference, because there'll be the different forms of polynomials that you'll need to factor. Okay, and again, once we have it in factored form, if a factor in the numerator matches one in the denominator, they're common, and that's when you can cancel them like we did on the front. Okay, remember, we cancel factors. You can never cancel terms. All right, so let's go ahead and start our first one. So this is a quadratic-like trinomial. We have even degree to the fourth here, okay? That's why it's quadratic-like. So we're going to do the same thing we normally do. We're going to multiply our AC. And for this one, A is 1, so it's a little bit easier. But remember here, we put our AC multiplication. That's negative 50. On the bottom, we put our B term, which is 5. And we want those two numbers that multiply to negative 50 and add to positive 5. And those two numbers are negative 5 and 10. Okay, so we're going to break this one up. Now this one's easy because A is 1. You don't have to go through the whole method of factoring by grouping. So we can just quickly set it up. X squared minus 5 times x squared plus 10. And there's your numerator factored. Now in the denominator, you want to notice, again, we have a fourth power. So it's quadratic-like. 25 is a perfect square, so we can break this up. It's a difference of squares. So we group our first two, last two, do our x squared for each one, 5 and 5. One's a plus and one's a minus to cancel out that middle term. At this step, again, factoring completely, you want to double check. Nothing else can be factored further. We have factored them as much as they can. And now we can look for common factors in the numerator and denominator. So I can notice I have an x squared minus 5 top to bottom. I can cross those out. Okay, they divide out. We have x squared plus 10 on the top left. And then on the bottom, we get our x squared plus 5. And remember, we are not allowed to reduce any of these because they're terms. They are the terms that make up the polynomials, not factors. And that's your final answer there, reduced. All right, so let's take a look at part B. So the first thing I want to notice is in the numerator, we have two terms, and they do have a GCF. So they both have a factor of 2 and x. So the numerator you can write as 2x times x, and then when we take 2x out of 6x, you're left with 3. Now in the denominator, when I look through, we don't have any common factors, but it is a trinomial. So again, we're going to do the same thing we did for part A. We're going to multiply AC. Put that on top of our x here. And my middle term goes on the bottom. And then two numbers that multiply to positive 6 and add to 7. And those two numbers are 6 and 1. So over here on the side, I'm going to make a note because our A is not 1. So we're going to have to factor by grouping. So we're going to do 2x squared plus 6x plus x plus 3. And then you want to group your first two, last two. Take your GCF out of each one. Remember here, we only have a GCF of 1, so take that out. The repeating one comes out. The other stuff makes up the second factor. So this GCF you took out there. All right, and so let's put that underneath. That's our new denominator in factored form. And now we look top to bottom, and I see I have a common factor of x plus 3. So I'm left with 2x over 2x plus 1. And now we have it done. And again, you are not allowed to reduce those because this is connected to that x plus 1. All right. Okay, let's go on to part C. So again, I'm going to look at my numerator. I notice I do have a GCF of 3, so I'm going to take that out first. I can always write it in factored form, or taking a GCF out first, making it easier to factor. And then I'm going to write this, and hopefully you recognize this is a difference of cubes. So I know, oops, we went over that before. So that's why you want to have those notes for the polynomials out if you don't remember that pattern for factoring. All right, so when I look at this quadratic, my a times c is 9, adds to 3. Nothing does that, so we cannot factor the numerator any further. We're just going to leave that. And then in the denominator, again, we have our difference of cubes. So remember, we take the cube root of each term. That makes up your first group. Now the second group, you take your first term and square it. So I get x squared. I do the opposite sign, so a plus sign. Multiply those two together, always positive, square your last term. And look at that, they match top and bottom. We have a common factor. We can reduce those out. We're left with 3 over x minus 3 as our final reduced form. Okay, let's try our last one here for D. Okay, so again, when I look, we have an even exponent here, and I have a perfect square and a perfect square. So that tells me I have a difference of squares, so I can factor my numerator into, remember we take the square root, this you split in half, so x to the third minus 1, and then 3x to the third plus 1. Okay, so that's your difference of squares here. And then the denominator, I have 4 terms, so I'm going to kind of go underneath here. So remember, when we have 4 terms, you want to group your first 2 and your last 2. Take your GCF out of each one. Take your 3x to the third out of the first group. That's going to leave you with x minus 3. And then the only thing we can take out here is a 1. And so we have our x minus 3 there. Okay. I take out my repeating. And then I'm left 3x to the third plus 1. And so I'm going to add that up over here. And I see I have a common factor that I can reduce out. So my final answer, we get 3x to the third minus 1 over x minus 3. Okay, so it just takes those concepts we've worked on. You should know how to factor polynomials. We've worked on that before, and then just reducing it down. Making sure, of course, most importantly, you're only canceling factors, never terms. Okay, so you have a big ideas assignment to practice, and hopefully you do well. Thanks.